Thanks, Renan. Yeah, as Renan said, my name is Jeff Bienkowski. I'm a retired career firefighter that through my career, I trained to the level of a hazmat specialist. And after retiring, I wanted to share my knowledge and my training with others in the fire service and trying to make our profession safer, because we read and hear about firefighters getting injured and killed through incidences at fire scenes. So in my search for an agent that is effective on today's 21st century fires, I came to find hazard control technologies and encapsulator agent F500, which we're going to be talking about. In this presentation, we're going to be talking mostly about lithium-ion batteries because it seems that it is the biggest growing hazard that the firefighters in the fire department and the fire service faces today. And it's rapidly growing. So to give you just a little bit of history about hazard control technologies, we are not a startup company. This is a product that's been around since 1997. So unlike many agents that are coming to the market and making claims that they're very effective and doing, being able to deal with these types of fires, this is a product that has been around. It's been extensively tested environmentally as well as in the hazards that firefighters face. So today we're going to discuss a little bit of everything, but basically I'm going to try to concentrate on the lithium-ion battery hazards. We are, as this slide shows, located in Fayetteville, Georgia, with distribution centers or points throughout the world. Today, as I mentioned, we're going to deal with the lithium-ion battery hazards. And when we sit there and we look about how popular the batteries are, they're very popular. No matter where we look, we turn around, probably within arm's reach of us right now, wherever we are, we're going to be able to see a lithium-ion battery or powered device. So they're everywhere. They're found in transportation now, our consumer electronics, our phones, our computers. Everywhere we turn around, we're finding that these batteries and their uses are growing. So when we look at the differences between, because you get a lot of times people talking about a lithium-ion battery or maybe a lithium battery, and there's sometimes maybe some confusion as to what's the difference between the two. So the main difference between the two is that a lithium-ion battery is considered a primary cell. Okay, it is non-rechargeable. Okay, it has lithium metal in it. It has a longer shelf life than the lithium-ion batteries, usually up to 4 times longer. Where when we sit there and talk about a lithium-ion battery, it's considered a secondary cell, which is rechargeable. And as we know from use in our phones, we can recharge them every day for years without losing much function. The power in these batteries is remarkable. So we need to understand these differences between the two types of batteries. Lithium metal, lithium batteries are non-rechargeable. Lithium-ion batteries may have some lithium electrolytes in them. They are rechargeable. So just so that we understand and have understanding of the difference. We start looking at the different styles of batteries. You got the cylindrical cells, the prismatic cells, or the pouch cells. And, depending on the types of devices that they're going to be used in, the shapes and the sizes of these batteries can vary based on the use that they're going to be. Just for example, with your cylindrical batteries, you got probably the most popular one that we talk about and we see most is the 18650s. You got the 2170s, and now because of again trying to get more miles out of a vehicle, longer distances, we're starting to come up with ways to make bigger batteries that can hold more power. We're starting to look at these 4680 batteries, which do just that, hold a little bit more energy, but again, at the same time, they're holding more electrolytes, and again, it's a little bit more of a energy supply. When we start talking about, and to give us some understanding as far as the terminology, when we're talking about a battery or a cell, it's usually an individual. When we start talking about multiple cells, okay, now those make up a module. And and we start putting a bunch of modules together, now we're developing a pack. Okay, and when we talk about, Teslas, and the battery packs and some of the other uses for these, okay, this is basically what people are talking about when they're discussing either a module or a pack or a cell, just to give us some understanding again of these batteries. And as I said earlier, based on the application, these batteries can change, from the modules to the cells to whatever is being used on. So the devices are going to dictate what the batteries and the cases may look like. And as we get into vehicles, okay, while we talk and we hear about the Teslas, and why don't we go back and we look at the previous slide, and I'll go back again just to point it out, the one here in the middle, which shows the EV battery, which for a vehicle. Now, when we start getting into some of the larger vehicles, okay, our trucks, okay, batteries just get bigger. And when we sit there and we talk about, the potential of a fire with an automobile, a car, let's start to also think about how much energy and the potential that these larger battery packs that we find on trucks and other modes of transportation bring. So we need to understand all the different uses, because it seems like when we start discussing and we start talking about fires dealing with lithium-ion batteries, we're always drawn to and start talking about Tesla fires. But that's not the case. We need to look at the entire picture, all the different areas where these batteries can start having an effect in the fire service. And when we start doing that, we then need to sit there and start looking at what can start these fires. Okay, the short circuiting because of an accident, because they become unstable, the trauma being dropped, again, those accidents, overcharging or overheating. And we talk about that exposure to the sun, phones. I know you sit there and you start thinking about it. And when we look at the makeup of these batteries, we've got combustible materials in these batteries, the electrolytes and so on and so forth, and things that can cause the fires or defects in manufacturing. If there were any impurities that were in the electrolytes that can cause internal shorts, design flaws. Let's look at, years ago when the Samsung phones were catching on fire. I've through reading articles found that it could have been caused by when they were assembling, it might have crimped the battery just in an awkward way, and because of that it was causing these Samsung phones to catch on fire. So design flaws are assembly, improper usage, people sitting there and using these batteries for things that they're maybe not designed for. We're getting a lot of people that are trying to, I guess, make things or design things, make automobiles, converting them, and without maybe the proper knowledge, they're not using these batteries properly. We are hearing now in the news a lot about chargers. If you're not using a manufacturer's recommended chargers, you're trying to be a little frugal, trying to save some money, and you go out and buy an inexpensive charger. It may not have the sensors, or it may not have the electronics in it that the manufacturer chargers require or recommend, which then doesn't shut the charger off if it starts to detect that the cell phone or the device is starting to overheat. So very important that we make sure that we use approved charging devices with these. And then, as we know from what happened recently down in Florida with the hurricanes, and all the flooding, the Tesla fires, how many were caused because of some of these EVs, these electric vehicles being submerged in the water. And then, when the salt waters, kind of resided, these batteries or these cars, batteries, started to catch on fire. So we know that, these wet conditions and humid conditions can actually cause issues and problems. When we sit there and we start traveling around this holiday season, let's pay attention, for all of these battery charging stations are starting to pop up. When we go to the airport, you start going into the parking structures, or you go to shopping centers in some of the larger cities, we're finding these charging stations popping up for our EV vehicles, in many locations. And some of the things that I've noticed when I've been in my travels and find these is that in a lot of cases, especially in these parking structures, these EV vehicles are given preferential parking spaces. And I find them in many cases close to exits. The disturbing part is we don't see any additional fire protection. And I'm going to talk about that as I continue on. But here you'll see, we've got these spots. You've got the one red extinguisher that's mounted on the wall on that top right picture, and that's all we have. We start getting into our warehousing and our manufacturing facilities. They're trying to improve air quality for their employees, getting rid of the the LP or the high-lows or the forklifts that are powered by your gas, LP gas, or your regular lead acid type batteries, and they're going into the cleaner and more powerful lithium-ion batteries so that they get a longer usage out of them before having to charge them, and they don't have the hazards you might have with dealing with all the lead acid type batteries as far as the fumes that are being released when you're charging those types of batteries. So it's a changing world that we have. When we talk about transportation, we look at city buses, school buses. You look at Thomas and Bluebird, some of the manufacturers that make school buses. The difference is here we're seeing these vehicles with the batteries on the top, and they have charging stations that they pull into. Again, as we sit there and we look at these and we look at the close proximity of these vehicles to each other, no additional fire protection, nothing there in the event that one of them is to fail. And we'll see why right here in this particular video. We're going to sit there and we're going to watch this video and we're going to see how we have the one vehicle that, it's starting to gas, it's starting to fail. As it does, you're going to start there, you start to see the extensive, flames, and you'll actually start to, in the bottom underneath the van, you'll start to see some of these batteries that start to pop out. You see it with Teslas, and you see it with other battery powered vehicles. As they sit there and they start to burn, the batteries will explode and they'll start to fly, and you got projectiles. And that's one of the things that I'm going to talk about as we start getting in and discussing that extinguishing, because it's a matter of trying to get these batteries cooled and being able to stop that thermal runaway or thermal propagation from battery to battery, and being able to deal with these. But the point that I want to make with this particular video is, again, let's think back to that picture I showed of that parking garage where you've got multiple spaces for electric vehicles inside of a parking garage or underneath a structure. And we see that, how quickly it can be propagated, or it could go from vehicle to vehicle spreading. Now, the truck that was in close proximity to the van, its brakes failed. There was a failure, so luckily it rolled away. So we may think that because it was able to roll away from the vehicle that was next to it on the other side, that the fire is going to stop there. But again, let's think about how forceful, when these batteries burn, we can get those jets of flames that shoot out. So even though that truck is rolled away, it's still able to throw those flames out, that heat, and that fire is going to continue on down. And again, let's think about that parking garage, that parking structure. If it's, these vehicles are close to exits, okay, are we really thinking that, where these charging stations should be and should be placed? When we sit there, we start looking at these, and you often hear people talk about, well, just let them burn. It's not always the case. We look at the scooters that we keep hearing about and seeing in with for some reason I can't get that video to play. Well, let me go to the other one. This one is showing the laptop computer. Again, just sitting in a chair charging. We don't know what the condition was of it, but it's just has a fault in the battery. The battery catches on fire, and we can just see how explosive and how forceful that battery burns, and why we sit there and we start singing. I was able to get this other one to play. We were able to hear that little snap and the pop. And the reason why I want to show this one is because in New York, we keep hearing about all of the incidents where they've got these e-bikes or these scooters or hoverboards or other personal mobility devices that are catching fire and causing huge issues within New York. And most recently, I think they just had one here a few days ago where they had like 38 people that were injured. So, these are becoming a huge issue and a problem. And again, the causes of some of these can be using a non recommended charging device, or a charging device that's not recommended by the manufacturer. We get our e-scooters and we see again just how these can go, how effective the fires are. But the thing is let's look around. It appears that they've used a powder. It appears that they've used water, and they have not been able to stop the thermal process, the heat. So even though they've tried to extinguish it using water or powders, it's been unsuccessful, and the fire has just reignited. And as we continue on, we'll discuss and see why, when we start looking at the encapsulator agent, the difference. And while we've talked about the smaller uses for these batteries, we need to also look at some of the other things. We talk about the vehicles. Well, the power companies are looking for ways to help provide power during peak demand times without having to buy from other sources, buy power and bring it in from other sources. So they're starting to go into these huge battery energy storage systems. And they're using lithium-ion batteries. And what they're doing is they're during non-peak hours, when the electric rates are low, they're charging these lithium-ion batteries. And then during peak hours, when demand is high, they start to use these batteries to help feed the grid, to help meet the demand. And so they're able to, again, from some of these solar panels, some of these wind farms and things that they're investing in, they're able to collect this power and be able to add it to the grid and get it to our homes throughout, peak demand times. And I wanted to just draw just a couple examples, and this is just within here. When I talk about FDNY alone has reported close to 200 fires and injuries due to lithium-ion batteries. This has been probably with just the last few months. I mean, New York has been getting a lot of these fires, and right now they're considering, as we see, laws that address fires caused by these scooters. They're starting to work on trying to ban them from being able to be brought into some of these high-rise buildings and some of these different buildings. When I talked about those battery energy storage systems, okay, they're all over, but we've had some instances where they've had failures, and we're going to pick on a couple of them here. The one in California, which was some time ago, but we've had two that had happened in Arizona. One was in Surprise, Arizona, where the system failed. And in these battery energy storage systems, the ones that look like Connex boxes, or even some of the buildings, they're using inerting gases as the extinguishing agent of choice. And if we're familiar with these clean agents, they work well at being able to smother a fire, but as far as being able to reduce the heat, okay, be able to reduce the toxins in the atmosphere that these batteries are releasing, they really don't do anything. They're not helpful in that aspect. So in 2019, with that Surprise, Arizona battery energy storage system, we had a failure. And when the firefighters responded, they did everything they should have. They took their time. They got the experts on scene that were familiar with that battery energy storage system. They got the information. They got the information that they needed. They were using thermal imaging, trying to watch temperatures, see if they could get temperatures. But again, we need to understand, we've got this huge box. And after a period of time, they felt that, in order to get any more information, they needed to open up the doors to this battery energy storage system. And when they did, they had the right fuel mixture. They had, all the conditions they needed as far as the heat still being generated from the battery. The only thing is there just wasn't enough oxygen in there for it to burn. So when they opened up the doors, they had an explosion, injuring 6 firefighters, 2 career-ending. So it was an event that could have been much worse. And then recently here we had Chandler, Arizona. And I bring that one up because with this particular incident, while we didn't have an explosion and fire, we had a sprinkler system that activated for close to 2 weeks. Millions of gallons of water that were used in the efforts to try to extinguish this particular fire. And when we sit there, we start looking and we start watching in the news, how critically low some of our water reserves are, how areas of our country are serving or are being, experiencing drought conditions. Do we really have millions of gallons of water, or with just one car fire, thousands and thousands of gallons of water to be able to use on these types of fires? So in this one, I'm going back and I'm showing a video, showing the forklift with the lithium-ion batteries. And I'm showing this one for a reason, again, is because when we sit there and we look at all of our buildings, our schools, our hospitals, our warehouses, manufacturing facilities, what's the fire extinguisher that's required by code? Okay, we have dry powder everywhere we go, ABC. So when we sit there, we start looking at, the employees, they're scrambling around. They're grabbing these ABC extinguishers. They want to get this fire put out so that they can get back to work. So you'll see them there start coming in to the picture. And, as we look, we're going to see, when you look, you're probably from the angle that you can see, not on the backside because there's too much of the powder in the air, but there's probably about 6 or 8 extinguishers that are being discharged on this high-low. And it looks like they're having a pretty good effect on being able to extinguish it. And then, hey, we find out that no, it didn't work. And the worst part about it is here in a second, you'll see that the high-low, just like that truck that we saw rolling, away, here we have the high-low now rolling a little bit deeper into the manufacturing facility, and it was a total loss. What's going on here? I lost my. Excuse me. I'll be back in 1 minute, Hernan. My PowerPoint lost. I'm coming back. My PowerPoint closed out on me for some reason. Okay, I do apologize for that. So I'm going to go on to the next slide here. Yes.
Jeff, and this is Hughes Wick. I don't know if you read the name, but I work for an insurance company. And what about charging the batteries? And I just had a client ask me about, there's payback for the state of Illinois if they use lithium-ion forklift batteries in their manufacturing plant. Is the NFPA code addressing any differences in the spacing requirements for the chargers for lithium-ion batteries? Is anything that you're aware of with regard to that besides the fire hazard of the battery itself?
Again, that I'm going to say I'm not aware of any. And as you are aware, codes and standards, they come up for revision like
Right. And I don't think
every
we're up to
3 years.
Right. Yeah.
Yeah, and we're so far out of date with many of our codes and standards based on the advances in technology that we're light years behind where we should be
Okay,
with
and
technology.
again, I probably was late to this, and that was my main concern coming on, is trying to find out. I think this is being pushed really heavily in the state of Illinois with tax breaks and everything else for energy use, that we're going to see a ton of these coming in. And I was just curious what the history is, and you're showing the one fire on that forklift. Do you, is there beyond that a history of fires on these batteries and forklifts that you're aware
Not that I'm aware of, sir.
of? Okay.
But
All right, I'll leave it.
yeah, okay. I'm going to go through here. We'll finish up and then we'll get into some more of the questions here. But when we sit there, and again, not only are we dealing with those forklifts, but transportation. There's many of the tax breaks that are also going to different areas of transportation. Schools and industry, and well, hell, even within our municipalities. So the question now becomes, are you prepared? While again, like I just mentioned, the codes and the standards are light years behind the technology, and they come up for revision every 3 years. And to me, I think the need to start to address some of these on a more rapid basis, especially with these charging stations being put into parking garages or even into our homes, our condos, or wherever it might be. We need to start looking, and we need to start addressing these because of how rapidly we're looking at this new technology and how rapidly it's growing. So when we talk about the dry chemicals, as you just saw from that video, again, every building that we have, codes are, we need to use these, or we need to have these dry powder extinguishers. And as you saw, it's ineffective at being able to cool or extinguish. It doesn't remove the heat. It's doing nothing. The gases that are being released when these high-lows or these lithium-ion batteries burn, the dry powders do nothing to reduce those toxins. They don't prevent that reignition, as you saw in the video as well. So they're very ineffective at being able to extinguish a lithium-ion battery. When we talk about, and the next thing that the fire service is very familiar with is foam. But foam is very ineffective at being able to cool. Foam is a blanket. And what do we do in the winter through the cold months when it's cold outside? We put a blanket on, or we cover up. Okay, what do you think foam is doing? So it's not really doing much to remove the heat. We'd look at the toxins that are being released, the HF gas. Again, it's doing nothing to be able to reduce that. If anything, we're adding to the toxicity because of the PFOS and the PFOAs that are on our Class B foams, if that's what we're using. It's doing nothing to help the environment. We can be adding to. Not only that, but if we're using hundreds or even thousands of gallons of water, where is all that runoff going because of the toxicity of the electrolytes in the batteries? So foams aren't an answer. Neither is plain water, as we know, because we keep having those reignitions. Same with the foams. So it's ineffective, again, at being used on lithium-ion batteries. Inerting gases that I mentioned when I was talking about the battery energy storage systems, the BESS systems, they are great uses for data centers, computer centers, switch rooms, and other things where electronics or other sensitive equipment might be used. These clean agents are effective for those types of things, but they are not when it comes to lithium-ion batteries. They're not doing anything to help cool. Okay, they're not doing anything to reduce the toxins or the hazards in the gases. Okay, the unburnt fuels, I guess you can say. If anything, they're making conditions even less safe. The reignition is very high probability. So these inerting gases are absolutely, to me, useless when it comes to dealing with energy storage systems or firefighting of a lithium-ion battery. Water, I know all the experts keep touting as water being the most effective and the only thing that can put out a lithium-ion battery fire, and it's copious amounts. And each and every time we hear about a vehicle fire, we're hearing, hey, they use 30,000 gallons of water. They use 40,000 gallons of water, 60,000, the amounts of water that are being used on these vehicles is just, to me, phenomenal. You're using almost as much water to put out a single car as fire departments would use to put out a structure fire, a house fire. And it's, to me, a very ineffective way to extinguish, but yet that's where all the experts, or the so-called experts, are leading us here in North America, in the United States. Again, when we sit there and start looking at the toxin reduction, okay, water's doing nothing to reduce those toxins. We look at the reignition, okay, how many times have we heard when water's been used, hours, days, possibly even weeks later, these batteries reignite when they've been put out with water. So we need to sit there, we need to rethink, because if we're using that much water, where is all that runoff and all that toxic water going? Because again, the electrolytes and things that are in these batteries are very caustic and very, very hazardous. So let's get into and talk about how we can sit there and deal with these fires and make a little bit, I guess you can say, better effect on being able to extinguish. And as I said early on in the very first slide about hazard control technologies, we've been around since 1996. This isn't a startup. This is a product that's been around for many, many years, extensively tested, a lot of environmental testing as well. Been tested for PFOS and PFOAs, for which there are none. So there are none of the forever chemicals, the things that are causing problems, and it's biodegradable. It's not going to stay in the environment. There is a standard for it, and it's NFPA 18A, which is the standard on water additives for fire control and vapor mitigation. And I mention that because all through the presentation, we've talked about, being able to reduce the toxic vapors, the toxicity and things like that with the batteries. And, water doesn't do it. The inerting gases don't do it. The foams don't do it. The powders don't do it. But now we have a standard that talks about being able to mitigate vapors. And we're going to see how this agent is able to have that type of an effect when we talk about not only lithium-ion batteries, but one, as you see here in this, standard, it works on the A, B, D, and your three-dimensional fires. Again, fires that foam cannot extinguish. And if we go to an NFPA 11 standard and we look at Annex A11, you'll even see in that standard that it states foam is not suitable for three-dimensional fires. And this is an agent that works on hydrocarbon fuels as well as polar solvents. When we go on, I want to now talk about Annex 4.3 in the 18A standard. If we go there, this is currently the only NFPA standard that I am aware of that has any information about testing of an agent on extinguishing lithium-ion battery fires. And that's where I start to talk about, again, here in North America, we seem to be a little bit behind many other areas of the world. There's been extensive testing in Germany, starting with with Bosch, I believe back in 2008. So it's not something that has just started over in Europe. They've been doing this testing for years and years, knowing and understanding that this was going to become a growing hazard. So they're light years ahead of us. The testing is including that Kiwa Labs, Dacra, Daimler, Deutsch, Bosch, like Fraunhofer University, and we'll talk about some of these, and even one that has happened and we came across most recently that really discusses. But as we go through and start looking at these batteries and the hazards that they pose, it's not just the energy and the electrolytes that we need to talk about, but you've got when they're in vehicles or they're in, phones or whatever it might be, you've got the plastic cases. I mentioned briefly about the Class B materials, flammable electrolytes, and then again, that shock potential as far as the energized batteries. And we're going to talk about how, we're able to have an effect in being able to work on all of these. So as we go through, I want to again mention that this F500 is 100% fluorine free. It has been tested. If as we go through and we talk about any of these reports or any of the information, again, more than happy to share it with you. The product is non-corrosive and 100% biodegradable. It is listed as an AB fire suppression agent and a combustible and flammable vapor and spill control agent. And we talk about that. We are on the US EPA's National Contingency Plan as a surface and soil washing agent. So we do have, as I said, many, many years of testing behind this
encapsulator tech.
To understand how the product works, you first need to have an understanding of a spherical micelle. Unlike foam, which makes bubbles, encapsulator agents make spherical micelles. To understand it, we need to understand our molecule. Our molecule has a polar head, which loves water, wants everything to do to be in water, and a non-polar tail, which fears water and wants to stay away from water. We can be mixed in any number of ways, batch mixed through these eductors, water-driven proportioners if we're talking about fixed systems. But once we get into the water, we create those spherical micelles. And those spherical micelles will travel through the water stream until they get out to either a sprinkler head or a fire nozzle. And as they come out, those water droplets that are formed, what happens is the molecules closest to the surface, they break apart and they put this skin on the surface of each and every water droplet. So I'm not making bubbles and working on a mechanical basis. I'm chemically changing the makeup of each and every water droplet and the characteristics and how they're able to extinguish a fire, okay, or encapsulate. These are water droplets are able to encapsulate fuel, vapors, and render them non-ignitable. And it's able to reduce the toxicity of the soot, the smoke. These droplets are amazing in all the things and all the effects that they can have in being able to reduce the hazards that firefighters face in not only dealing with lithium-ion batteries, but everyday fires. And we've got some really, really extensive test reports that are starting to come on just that. So, again, understanding, and it's very important. This is probably the main thing that I can stress is how this product works, is understanding that the basic building block of F500 and an encapsulator agent is the spherical micelle. Excuse me. So again, just a real quick animation or a picture here showing, as it comes out of the nozzle, those droplets closest to the surface break apart, they spin out, they create that surface. And what happens is we, in the process of changing the mechanism of how these work, as far as being able to rapidly cool and drop these temperatures down, we're also able to drastically reduce the flammable electrolytes that are in these batteries. Okay, we encapsulate them. And by doing that, that potential for being able to have that reignition is reduced. Because what happens if we're using water to try to extinguish a lithium-ion battery, you still have flammable electrolytes, and you haven't really done much to reduce that heat. So why are these batteries reigniting? Well, days or weeks later, if there's a little spark that starts to form, we still have flammable electrolytes in the batteries. We just talked about the ability of an encapsulator agent to be able to encapsulate those flammable electrolytes. So I'm getting rid of that hazard. We talk now about the ability to rapidly reduce heat. We have many tests that show that, we're able to rapidly reduce temperatures. We take temperatures in excess of 12 and 1300 degrees, and we're able to drop them down to 120 degrees in a matter of seconds. And that is one of the main things that, we keep hearing about, that thermal propagation, that from battery to battery to battery. And if we can cool down and we can stop the thermal runaway within a battery and stop the thermal propagation within a module or cell, that is being able to now stop that fire from continuing to burn on. So we look at now the toxins that are being released. HF gas, the hydrogen fluoride gas that's being released when these batteries burn. Again, it's a danger to people's health. There are IDLH levels. So when these batteries burn and they start giving off these toxic fluid fumes within buildings in high-rise structures that are, New York is faced with, pretty much it seems like almost daily basis we're hearing about some type of a fire with lithium-ion batteries. It's causing a life safety hazard within these buildings. But yet we can show with testing that F500, when used to extinguish these battery fires, it reduces those toxins and those gases drastically. So the effectiveness of F500 on lithium-ion batteries is in all the areas none of the other agents have been able to prove they're effective on. The F500 is able to rapidly cool and stopping that thermal propagation, stopping that thermal runaway. It reduces the toxins that are being released when these batteries burn, making scenes safer, reducing firefighters' exposures. I mean, firefighters are exposed to many things, carcinogens and others. Here we are seeing that encapsulator agent works on being able to reduce all of these cancer-causing agents that the firefighters are faced with. The electrolytes, we again are going to talk about being able to encapsulate those electrolytes, rendering them non-flammable, reducing that reignition source, and how, again, effective the product is in needing much less water to be able to extinguish these fires. So just a real quick comparative. This comes to us with Kiwa Labs, our HCT Europe, and Johnson Controls. Johnson Controls, the largest fire protection company in the world, was looking for third-party independent testing for one of their customers. And they came to HCT Europe and asked if they could test F500 against all of the products they make in the United States and in Europe. And we see how powders do not work. In the middle, we see foams, but on the right side, you'll see with the F500, he's just using short little duration, short little squirts. With the foam, constant spray. With the powders, constant spray. Very ineffective. Okay, we can't cool. We can't smother the fires. Okay, but yet with just a small amount of the F500 encapsulator agent, they were able to extinguish that battery. We start looking at right out of the published report by Johnson Controls after the testing was done. In the series of tests that they conducted, the powders were poor, not recommended, do not apply. The foams were moderate to poor, but not recommended to apply on lithium-ion batteries fires. And then the F500 was sufficient all the way across the board. And if we do a Google search for Johnson Controls and lithium-ion battery fire protection or fire extinguishers, you're going to see that over in Europe, they are actually selling fire extinguishers with F500 in it. And we look at the conclusion, they have here. The F500 can be recommended to apply on a lithium-ion battery fire, taking in the account of the lithium-ion battery is without danger because of the possible explosive behaviors of lithium-ion batteries. And we see that in our videos. You'll see those 18650 cells, and we'll see those batteries, flying off as projectiles and things like that. So even though it's effective, we need to be aware of When we look at the testing that was continued on now by Thiel Clausel University, they started looking at that HF gas, and they wanted to find out, because encapsulator agents, are able to encapsulate flammable vapors and others. They wanted to do testing and see how effective it was on being able to encapsulate these HF gas emissions that were being released with the batteries. So from the testing, they were finding out that without trying to extinguish the batteries, when these batteries would burn, they were giving off anywhere from 227 parts per million up to 2656, depending on the size. Now, when they used the encapsulator agent F500 to extinguish the batteries, they dropped those levels down. The highest levels they got were 37.45 parts per million. And we sit there, we start going to the AEGL, acute exposure guideline. And, we look at that, and, that is almost a 30-minute acute exposure guide. So it's giving us a little bit of a safety margin in being able to reduce the HF gas that we're being exposed to. So if we start putting these types of extinguishers in some of our workplaces and some of the other areas where these lithium-ion batteries are found, if these batteries fail, we're giving ourselves some safety in being able to knock down or reduce those HF gases that are being released. When we sit there and we start looking at the wastewater, the runoff, again, much less water is needed to be able to extinguish these batteries. So when we look at the water runoff, it's showing that water plus a 2% F500 concentration before extinguishing, it lists all the things that were found in the water. When we sat there and they start using it after extinguishing, and they're only talking about wastewater of 7 liters, they found that, there were some additional, some metals and stuff to that, but the conclusion was that the extinguishing water contained very low concentrations of heavy metal parts. And so they could, by adding and diluting it down and rinsing the water, they can have acceptable values where it can just be released into your normal wastewater treatment facilities. We talk about, again, some more testing that was done by Clemson University, and this was with burning toluene. But again, it's showing the ability of this agent to reduce the hazards that firefighters are exposed to in our fires. And when they were doing this testing, they used an inverted glass funnel, and they were looking at 3 things, light transmission through the smoke column, the buildup of soot, and then the toxicity of that soot and smoke. And they ran a series of tests. And then in the other side, you'll see that they used a 3% solution of the encapsulator agent F500. The results were that when they looked at, wrong slide, what's going on here? My slide lost. When they sat there and they started looking at the results were there was a 68% increase in visibility through the smoke column. The reduction of soot was like 98 or 96% reduction in the accumulation of soot, but a 98.6% reduction in the toxicity of the soot and the carcinogens. And again, it's huge. When I talk to firefighters, and I bring this up because if you watch and you hear and you watch in the news, you may hear about a firefighter falling through a roof, or firefighters trying to do a search and rescue for victims maybe in a structure. If again we're sitting and we're looking at using this product, especially with some of these high-rise fires, here you have an agent that's going to be, before you start putting people on the roofs and doing horizontal or vertical ventilation, you've got an agent that's going to improve your visibility. It's going to rapidly reduce temperatures. Okay, so again, if there are victims, people in that structure, you're going to lower those temperatures down. And then the toxicity of the soot and smoke. We hear about fires 30 years ago that had natural fibers. People survived longer. Now that we're using so many synthetic materials in today's construction, life safety, or people are dying faster in these fires. Here we have a way to reduce those toxins and being able to help with their survivability. So when we look at this thermal runaway and ask the question, what is it? Here's all the things that are being produced when we're sitting there and we're looking at it. All the gases that are coming off these batteries, the carbon monoxide, the carbon dioxide, the HF gas that we've been talking about, the hydrogen. These are all parts of our gases that are being released when these batteries burn and what we're being exposed to, especially, if they're in a structure. And this leads us to a study that we recently found that came to us from China. I'm going to give Hernan credit. He's kind of, through a Google search, was the one that found this particular study. And it was a study that looked at the spherical micelle encapsulator agent and investigated it and looked at the ability of cooling capacity when it came to these lithium phosphate cells. It looked at the gases that were produced when they batteries burn it, and they collected and analyzed it. And then again, it started talking about the cooling capacity of the 3% solution. And they compared it with a water mist, because water mist seems to be, a trend that people think is very effective. And it's one of the other things that they were evaluating is the amount of hydrogen that was being released when they were doing these tests. And as we go through and we look at this report, here's a pie chart that shows, the hydrogen that's being released, how much of it was being released. And I'm showing a comparative chart. When Hernan shares this webinar with everybody, I'm sure he'll also share this report in its entirety, just so that you can have that and be able to review all of it. It's an extensive report that really talks and covers a lot about the spherical micelle from a third-party view. It wasn't anything that HCT had any input on. But when we look at this pie chart, and then we go over to the graph next to it, to the right of it, we'll see that the amount of hydrogen at its peak, without using any additives, they were at 476 parts per million. When they looked at the water mist, okay, they were able to, with the water mist, drop that hydrogen down to 217 parts per million. But when they added 3% of F500 into the water and they used it on these, they were able to drop the hydrogen down to 14 parts per million. Well, let's think back to that battery energy storage system that exploded and injuring those 6 firefighters. We had hydrogen gas, we had an explosive atmosphere, and all it needed was that right amount of oxygen coming in and that air fuel mixture to be right, and we had that explosion. Here we are right here in this test, able to show that we're able to reduce those explosive atmospheres when we're used in fire protection systems. And it's not just in these Connex box type systems, but if we start getting into the large buildings, the larger systems. When we do our presentations, we've had, and talked about the fire tetrahedron in the fire service. It's like day one, and we understand that if we have an effect on any one of the 3 legs of this triangle, we're able to extinguish a fire. And from this report, again, they're validating the things that we've said in our trainings with fire service for many years. Okay, we're able to encapsulate that hydrogen, so we're able to reduce these fuels and these gases. And it's not just the hydrogen, but it's other fuels as well. How we're able to interrupt the free radical coalescence, that black smoke, that soot. How we're able to reduce and oxygen, generate oxygen, in smoothing the effects of it, and then the cooling effect, the rapid and permanent heat reduction. So again, removing the heat, remove the fire. So we have in this test report all the information in how effective the encapsulator agent F500 was on all aspects of that lithium-ion battery fire, as well as so many other types of fires. There it is. Got slipped into the wrong place. This is that Clemson report showing that 68%, the 97, and the 98.6. So when we sit there and now we'll get into all the other things that were listed in the report, it showed that in the NFPA 18A, the encapsulator agent worked on all classes of materials. And we'd look at, again, a vehicle, Well, we're dealing with multiple classes, not just the lithium-ion batteries, but we do have many Class A materials that are also involved in these vehicles. We see that we're able to have an effect on being able to extinguish these Class A materials and also reduce those carcinogens and the toxics being released. The Class B fuels are important in the event you have a multi-car accident. There may be a electric vehicle as well as a vehicle that's powered by gasoline or diesel or some other type of a fuel. These spills can be hazardous, especially if we need to do extrication. We need to start getting people cut out of the vehicles. So it's important that we are able to identify and work at making those scenes safe. Okay, and being able to get people extricated out of vehicles and taken to safety. The main thing is the workers, the firefighters, all the medical people that are doing and working on life safety at these accidents. Okay, we need to make those scenes safe, and encapsulator agents can encapsulate those fuels, rendering them non-ignitable, and keep those scenes safe. Class D metals in vehicles. The average car, when I last looked here a few years back, average is about 380 pounds of a Class D metal is in our average vehicle. And if we look, codes and standards are stating don't use water on any Class D metals because of the explosive hazards. And when we sit there and we start looking at it, what causes the explosions? The heat at which Class D metals burn at is in excess of 3,000 to 5,000 degrees, okay, causes the water molecules to split into its two properties, hydrogen and oxygen. Well, in that China report, what did we talk about? The encapsulator agent was able to do encapsulate and reduce the hydrogen. So again, when we start using the encapsulator agent and trying, and I shouldn't say trying, but in extinguishing these Class D metal fires, okay, we're able to rapidly cool and reduce those temperatures. We're able to reduce that hydrogen, reduce those explosive gases. So here we have a water additive that is able to extinguish a Class D metal fire without having these explosions. And we have systems that have been very, very effective in such things. Excuse me. So when we sit there, we look at the solutions. We have multiple services. I know fire departments. I keep every time we see a vehicle fire, or every time there's a fire that's involving a lithium-ion battery. Things that I hear coming out of the fire services, we need more training. It's here. It's understanding that you have an agent that can work on these types of batteries and these types of fires that is fluorine free, that is environmentally friendly and safe, and is very effective. Okay, so we are able to help out not only the fire service but industry. Anybody that would like, just please contact your local HCT rep. We'll be more than happy to work with you and try and get some training set up to help you understand encapsulator agent and the F500 or any other types of fires that you might have a need to be able to deal with. But again, when we look at this, the agent of choice by Johnson Controls, Bosch, Tesla, and many others, because I always throw the question out there when I hear people talking about these fires is I've never heard anybody ask a manufacturer of these batteries what they use to protect their facilities. And you know what? In many cases, we're going to find out that it's F500 that they're using. So we have multiple ways to help out. We've got the mobile carts, extinguishers, our QAMUs, our quick attack mobile units that come in various sizes, carts, leaders. So there's many ways that we can get the product there. Our compressed air units. We have
Fire Rover is the revolutionary way to stop fires before they begin. using military-grade thermal cameras to detect abnormal heat variations and up to 20,000 gallons of firefighting agent, Fire Rover protects your business from property loss and downtime. Here's how it works. The thermal camera detects changes in surface temperature. Abnormal heat triggers an alarm and alerts Fire Rover's live monitoring station. Trained operators evaluate the risk and can trigger the firefighting agent remotely within seconds. Operators aim the firefighting agent using both thermal and HD footage. The firefighting agent is 100% biodegradable and effective on metals, petroleum, plastics, agriculture, rubber, general waste, and more, including lithium-ion battery hazards. Fire Rover can reach a distance of 150 feet with a radius of 343 degrees. The thermal camera confirms when the fire is extinguished and the surface has cooled, eliminating the need for costly fire watch. Fire Rover is always ready to detect and extinguish fires and keep your operations safe. Contact us today to start protecting your business.
So F500 can be introduced into sprinkler systems in multiple ways. We have, as you see on the top left, a concentrate control, basically what many fire protection companies are familiar with. Firefighters may be used to seeing in some facilities. It's a tank that holds the concentrate. When the sprinkler system gets activated, there's the bladder inside it gets compressed and squeezed and pours the concentrate into the water. And then we have water-driven proportioners and other diamond dosers that we call our water-driven proportioners. Are very, very effective and very great at being able to feed multiple risers. We're more than happy to work with any of our fire protection companies in working with that. So as we go in and we start looking at all the ways that we can help and start to address areas where, all of these charging stations are being installed, we need to sit there and we need to, instead of trying to wait for codes and standards to change, we need to be, I think, a little bit more aggressive. We need to be a little bit more proactive. And as these agents or as these systems or these charging stations get installed, we need to possibly maybe at a local jurisdictional level start to look at requiring some of these fire protection systems and being able to deal with the hazards that these batteries are bringing. And when we sit there and we start talking about, encapsulating the world, you're in good company. Here's a list of just a few around the world, the leaders that are working and using encapsulator agents to protect their facilities and lithium-ion batteries. So, it comes to, are you prepared? Here we have a vehicle, and, I show this one because of just how, again, explosive these batteries can be, and you'll see here in just a second. Here you have, a vehicle that's burning, and how violently. So when we sit there, we talk about being able to rapidly cool and start getting onto these batteries to prevent these types of explosions and these types of hazards. It's important. It's not something that we can do. So, you get into it's time for us to wake up. It's not, let's wait for, the next revision cycle. We need to start taking a proactive approach. We need to get the training out. We need to get the testing. Here in Europe and other countries, we've got years and years of testing, but yet, unfortunately, it seems that we're slow to adopt any of that testing here in the United States. For some reason, we think that we need to do that same test here in the United States in order for it to be, I don't know, accepted. So, when we sit there and we look at this, yes, we are part of all these different groups, these different organizations. We do sit on committees, technical committees, helping to change these standards, helping to push this technology forward. But as I've said, it's a matter of having to wait for these revision cycles to come around before we can take any actions. So it's a slow process, and the thing of it is we learn things from other testing in other countries about the advantages that the F500 and the encapsulator brings. And if a standard is just finished its revision cycle and we learn something new about the abilities of this product to be able to deal with a fire in a certain category, it may be 3 years before we can try to introduce it and get it into a standard. So it at times can be very, very frustrating, to say the least. But we are an ISO 9001 company as well. Quality control and quality management is very, very important to us. And like I say, we're here to assist and help the fire service and our contractors in the fire service any way possible. So with that, again, here's our information to be able to reach out to us, info at HCT World as well. But, look us up if you have any questions. We're here to help. We're here to answer the questions. We're here if you're in the fire service to help with that training that you're looking for when it comes to dealing with lithium-ion batteries. And with that, yes, thank you all for attending. Alana, especially in Australia where it's 2 a.m., we do appreciate you. And as Hernan said, we'd be more than happy to change our times to be a little bit better as far as your times over in Australia. So just contact Hernan and we can get something set up, I'm sure. With that, I just want to say that, a lot of the things when we talk about the encapsulator agent, when we talk about the uses with lithium-ion batteries or the extinguishing of car fires, etc., it's a matter of being able to understand the agent and what we're doing right now and trying to educate people on how to properly use the product and how it can be used in helping to make firefighting with not only car fires but any types of fire much safer. So it's an education process, and I find in many cases when I go and I do a training or we get departments that will adopt and start using the F500 encapsulator agent, a department just down the road doesn't believe that it works. They've got to see it for themselves. So it's people understanding, and it's not it's a problem of them. I guess you can say understanding or accepting the facts. They need to see the product work for themselves. And that's where our education process comes in and why we offer the trainings as well. So with that, I want to thank everybody from wherever in the world you're from joining us. It's been great. It's been a pleasure. Hernan's going to be getting this webinar out to you here shortly. He will attach the different reports and the different things that were part of it and the information to contact us. So if there's something you're looking for, please get in contact with us. We'll be more than happy to share it with you. Again, thank you. I enjoyed it. I hope you did. And thank you for your time. Have a good day.